Fantastic. Hi guys, welcome to this webcast or a recording of how to design lighter products. I'm doing a chain of videos. This is one of the first. So today we are having a look at how SolidWorks Simulation can help in designing lighter products. Before we start, to introduce myself, I'm Kapil Gaitonde. I'm the technical manager for simulation products. I'm based in Singapore and I'm covering all the South Asian countries, Australia and New Zealand for all the simulation products. More on the pre-sales, helping you all understand how simulation products work and how they can be implemented in your design cycle. So before we get into the exact content of this webcast, my idea would be more towards a quick lighter discussion. So if you see this video, apart from many other things, our highlight would or our eyes might go into this nice firm bodies, and obviously I believe most of us are striving to achieve this particular thing. And if I associate it with our discussion today, again, as I mentioned, lighter products, designing lighter products, and obviously apart from the looks, apart from the strength, the stiffness, it is also a light product which you are seeing in front of your eyes. So obviously that is more appealing, that is more interesting. So this was on a lighter note, and this is what I am saying. But there is one more interesting article which I came online. You can check it for yourself. This is a particular airlines which encouraged its air hostesses to lose weight, and of course the perk which they gave was an opportunity to come on their magazine, their yearly magazine, or I don't know, maybe sorry, it is a calendar, not a magazine. And from an engineering perspective, one of the interesting thought was it was in a bid to reduce the aircraft weight and avoid hefty industry cost. So this was interesting. They were looking at that minor weight change, which can help in reduction in fuel, and hoping for better fuel efficiency. So you can see it can be in this way as well. But saying that, nothing against big people. Even I am a big man sitting down here. This was only on a lighter note to start off this particular video. So a few more things, more specifics now. Let's get into it. The challenge, of course, we all want to achieve it, but the challenge is having it right, having it of the right application or intent. So obviously, we definitely want it to be light, but in the meanwhile, it should also be stiff. It should also be stiff. So it should be stiff as well. It should be aesthetic, usable, and it should be more, how can I say, as per the design intent. So we obviously are looking for a mix of all this, and only seeing the words as well, we can say that this may not be as what we want, right? So this is what it is. Let's now get into the software and what we are going to see today. So if I take this particular image down here, you can see, I'll be using this particular example wherein we have a simple knob with certain ribs, certain that head, I would say, which is a certain thickness. It is a kind of cylinder which has a certain height, and a hole has been created at the center, probably more to reduce the weight of the component. Now obviously, as a designer, my thought would be more towards improving, changing, or having the best of all worlds. And if I say in simple words, I'm trying to decide the dimension of this particular rib. I'm trying to decide the height of this particular top knob. I'm trying to decide the cylinder height up here. And of course, maybe if at all I'm trying to lose some weight at the center of the top over here. So this is the way, these are the things which a designer might want to play with to reduce the weight, design a lighter product, and as per the design intent and expectation as well. Now the best place where you can see this would be in the software. So I'll get into the software. You can see here. the same knob. It has a certain thicknesses, you can see all those things. Now to start with, obviously I want to do a simple stress analysis, and for all new users I would always recommend trying out this tool called as Study Advisor. You can see here Study Advisor. um, you can see we start off with a certain kind of simulation. Moreover, this particular simulation advisor can help you in those initial stages where you're not sure on what kind of analysis to be done, what is the process, which kind of loads and boundary conditions to apply. So all those kind of things can be decided using the questionnaire that is present here. Obviously I'll not be using it today now, and I'll directly jump into the software. So here it is. I have the knob. Probably I'll create a new simulation study, and if I to quickly show you a few things, the material can be applied from here. Okay, the material can be applied. I can apply the fixtures at the appropriate locations. Let me get into the fixtures. So this can be applied, and as well forces, etc. But better off I'll use the existing study which has been created. Now, one important fact, if at all the material has been applied in SolidWorks CAD part of it, it is automatically taken into simulation. Thereon, in terms of reference geometry, yes, what I'm doing is I'm fixing it. I'm selecting the internal surfaces down here, and I'm saying they are restrained along a certain axis, not to rotate in the circumferential direction. You can see it here. Number two, similar thing, it is the bottom part of this cylinder. Again, this is restrained in the Z direction, and being restrained from not moving in the positive Z direction. So those two restraints or constraints have been given to this part. It cannot move in those directions. Next is the torque, the force that is used to rotate this knob. So all those surfaces which are exposed to a particular hand or some gadget used to rotate it are being used to apply the torque. It is along an axis, and a 50 Newton meter torque has been applied, which can be seen as almost 6 kg force. That's it. This is a simple static analysis setup, and I typically mesh it and solve it over here. Quick simulation, it goes on fast. Probably I also have a good machine maybe, but this is how it looks. So as expected, these stresses are somewhere at the joint here. Definitely there is scope for improvement of the mesh, but this is how it looks. It is not crossing the stress limits. It is fairly okay on those aspects, all good. But definitely other way around, this is also telling that it is over designed and there is scope for improvement. Okay, so here it is. Here is the display. I animate it. You can see here. So clearly the torque is getting into effect, and we are seeing the displacements. Again, not a huge value. We are seeing an exaggerated thing at a scale of 12, but the displacement is hardly 0.5 millimeters. Okay, again, an indication of over design. So fine. Now let's move into the most important topic which we are seeing today, which is optimization. I create a new design study here. It is called as design study. So over here you can see there is a checkbox which can be selected for deciding the optimization details. But most important, I would like to have a quick discussion on these three things which are going to drive the dimensional details of your object. So first we have the variables. um, Number one, yes, the object in itself has a few different variables which you can see there. uh, Typically being a parametric model, it does have those details. We can as well add a few new parameters if at all you want to do that. By the way, all these have been created by me, they were not by default. Okay, we can directly select appropriate dimensions from the front end over here. Now that particular dimension was already selected, so we got the warning. So I can directly go down here and select different dimensional details. So these are the parameters which will be used for playing with the dimensions. Obviously designer has to decide this, that would be his role in this particular optimization technique, and thereon, based on the range that we are giving, here the model would be optimized. Second is the constraint. Obviously, we want to control all these things within a certain constraint or a certain limit. So that can be done using factor of safety. We want to ensure that the factor of safety is always greater than 2, right? That is one of the requirements down here. So that is done. And finally, goal. So our thought would be always to minimize the mass. Obviously, that is the idea today. We are designing lighter products, so I want to minimize the mass. So this particular optimization run would be triggered, wherein it would try to reduce the mass, keeping in mind that the factor of safety is always greater than 2, and the variables that it can play off will be given through the variable options. So this would be the most important thing that you would be doing in this particular simulation. Okay, so let me get into this study which has been created already down here. So you can see it has few different parameters as those I showed you before. So if I take an example of the rib thickness, we are saying it can vary between 1 millimeters to 3 millimeters. Whereas cut depth, it can vary from 1 to 10 millimeters, cylinder height from 11 to 15, cut diameter from 2 to 9. So these are the different variables that can vary. Hmm. Second is the constraints. If I take one of the constraint, which is factor of safety, we are saying that it should be always greater than 2. So we want to ensure a minimum factor of safety of 2. Finally, the mass, as we discussed, we want to minimize on that. Let me show you the table view. I can leave that, but most important is this one. So if you see this is the way, or these are the different iterations that the software has done. In this case, it is around 25 iterations, and it starts off with an initial dimensional detail which was somewhere like this. It had an initial weight of 48, and it is giving us an optimal design which has a weight of 38 and factor of safety of 2.5. So factor of safety is almost same, whereas the weight has been reduced. So obviously it's a big deal. 10 gram for this model can multiply into many other bigger values. Okay, so but what happens, typically the software will iterate. Now these iterations are not given by us, but the software decides which can be the possible values, and it will optimize at those, try to find the factor of safety at those particular values. So you can see a few iterations with the pink mark, which is nothing but telling that this particular iteration is not feasible. In this case, you can see the factor of safety is 1.88. So it is obviously below the limit of 2. Same, whereas iteration 3 is similar. Iteration 2 is feasible, but there are other iterations, especially the one which is shown as optimal, which is better than that one. So in this way it proceeds, it goes through the different iterations, and it comes back. By the way, it is not solving for all these iterations. Some could be interpolated, some could be accurately calculated, but it had its own technique to do all these details, and it comes up with the optimal iteration. Now in this case, you can see the cut depth is 5.5 millimeters, and other details are okay. But typically, as a designer, one might want to change this 5.5 to something that is more manufacturable and proceed with the design. But most important, you can see the model is getting updated as and when I click on these iterations down here. So if I take the optimal size, I can select it. I can go to this simulation study that has been created. I can trigger one more solution down here and get the other values of results like the stresses, displacement, strains, and all other things. Finally, once this is done, if at all I want, I can go to SolidWorks CAD and go and create drawings out of it for manufacturing purpose and other finer further details. So this is the way it is well integrated into CAD part of it as well, and can help in having your designs getting manufactured faster and better. So this is what I wanted to highlight in this first video. So in conclusion, we saw how SolidWorks simulation can help in optimizing your designs and help in designing lighter products which abide to your design intent. Most important, not only light, but they should abide to your design intent. The strengths should remain same or better. So that is it for today. Thanks a lot for attending this